Okay, here we are, section 2.4, and what this deals with are what are called one-sided limits. So far all we've looked at are limits, but now we can actually break it down into two different sides. We can be coming from the positive side, or we can be coming from the negative side. And so if we look at example number one specifically asks what is the limit as x approaches 0 of that particular graph. Well, looking at the graph, we see that both sides go right to the y value of 0, and so the limit would actually equal 0 in that case. However, there are some situations where that doesn't quite fit. And let's look at number 2. And here we do need to look at the way it appears. We get this situation right here. The limit as x approaches 2, and what this means is from the left or from the negative side. So the limit as x approaches 2 from the left of f of x. Well, if we look at this particular value, f of x, or f of 2, equals 1. That's that filled in point right there. However, the limit as we're coming from the left going towards 2, it seems to be on the line y equals 5. And so that would be the limit. We're approaching it. We may never get there, but we are at least approaching it. And remember, that limit is where are we approaching. Likewise, we are asked what is the limit as x approaches 2 from the right of f of x. And if we look at that, going towards where x equals 2, coming from the right, we see that that line is y equals negative 2. And so the limit would be negative 2. So here's a fairly succinct example. F of x, or in particular f of 2, is equal to 1. But the limit as x approaches 2 from the left of f of x is equal to 5, and the limit as x approaches 2 from the right is negative 2. So we have three entirely different values, and we can certainly ask, what would the limit as x approaches 2 of f of x be? And the question, or then we have to realize it does not exist, because it comes from it approaches two different values depending on which way we come from. With that in mind, look at what that implies. Wouldn't that imply if we have a limit, then wouldn't both this limit here and this limit here, those both would go to the same place? And so that is a good rule to know. If a limit does exist, then that means the limit as x approaches the value from the left as well as to the right will be the exact same value. If it does not exist, then there's a decent chance these are different. Example number 3, it says determine the limit by sketching an appropriate graph. And we're told f of x equals x squared plus 2 whenever x doesn't equal 3, and whenever x equals negative 3, then we know it's equal to 0. So what we get here, first thing we need to do is to draw a sketch here. So that's what we're going to do. We know that when x equals negative 3, f of x equals 0. So we do have that point there. But if we look at x squared plus 2, well, x squared plus 2 we know has a vertex at 0, 2, and then it has certain points. And we get this parabola that looks like this. Realize it's just the parent function x squared raised by 2 units. Goes 2 units up. And so this point normally would be on the x squared curve would be negative 3, 9. but since it's been shifted up 2, this is actually at 11, just for the sake of what we're looking for. Because we're asking, what is the limit as x approaches -3 from the right, or from the positive side? So we're going along from the positive side, we're getting closer and closer and closer, and the limit appears to be 11. So the answer here is 11. However, f of -3 actually equals 0, but that's okay. The limit is, where are we approaching it? We are approaching 11, even though the actual value is way down here at 0. So the answer to number 3 is 11. Number 4. We are asked to find the limits for these next two problems, and they are either from the left or the right. Now, realize the way that I'm going to teach this probably isn't terribly mathematically sound, but it does work, and it does require you to think things through. Am I going positive, negative? What's going on right at this point? So, if we look at number 4, the limit as x approaches -1 from the right of x over x plus 3 times 4x plus 8 over x squared plus 3x. Okay, now if we were to plug in -1, let's see, could we even do that? -1 would be, this denominator would be okay, -1 down here, this denominator would be okay. So, this, we can pretty well plug it in, because we look at the limit as x approaches -1 from the right. Well, the limit appears to exist here. The limit itself, the limit as x approaches -1, seems to exist, so that's all we really have to find. So this is relatively simple. It's just a simple substitution. We're going to get -1 over 2 times, let's see, -4 plus 8 over 1 minus 3. So this will be -1/2 times 4 over -2. And notice the negatives will cancel each other out, and we're left with the answer of, what, 1? So the limit's very easy. When the limit, regardless of whether it's from the positive side or the negative side, if the actual limit without that exists, then that will be the answer. Let's go and look at example number 5. Example number 5, if we attempt to plug in -4, we run into problems, because as soon as we put in -4 into that fraction, we get a 0 in the denominator. Plus we get 0 over 0, so it becomes indeterminate. So how do we go about doing this particular problem? Well, what we're going to do is we're going to look, and we're only interested in from the negative side, okay? So, or from the left side, as we're approaching from the left. So let's look at it this way. We have the limit as x approaches -4 from the left of x plus 3 times the absolute value of x plus 4, x plus 4. Okay, what we're going to do is we're going to, a couple things happen here. We get this. We can't just simply say x plus 4 over x plus 4 equals 1, because this is the absolute value. But what we can do is we can think things through. We are doing -4 from the left-hand side. So, values would be -4.001, 0.1, maybe even as far away as -5. Who knows? But see, when we put in -5 here, just for ease, let's put in -5 here. -5 plus 4 is -1, and the absolute value of that would be 1. So then the question becomes this: how can we rewrite this without the absolute value bars and still make the fact that we're coming from the negative side of -4 work? Well, if we put in -5, -5 plus 4 is -1. That doesn't work. We need the positive one. So how can we do that? All we really have to do is say, okay, let's take 4. Let's take -4 plus x, or -4 minus x. That is a way to change this so that in this case, since we're coming from -4 from the left, this will give us the appropriate positive value. So then this becomes this problem right here. The limit as x approaches -4 from the left of x plus 3, we can get -4 minus x over x plus 4. And now the question becomes, now that the absolute value bars are gone, we can look at, okay, how does this simplify? Well, this simplifies to the negative of x plus 4. And notice this x plus 4 will simplify with that x plus 4. So this whole thing now becomes -1 instead of the 1 that we thought might have worked up here. So what we get is the limit as x approaches -4 from the left of x plus 3 times a -1. Well, let's simply put the negative out there. Now let's see, can we plug in -4 here? -4 plus 3. Yep, -4 plus 3 will equal -1, which equals 1. And realize that all of these, both 4 and 5, can be verified by using a graphing calculator.